All right, next unit here, looking at our next topic here, looking at linear relationships and tables in our second lesson. A little warm-up activity today is just looking at similar right triangles to determine slope of each line. So again, we're just looking rise over run to find our slope of any given line. So that first line, if we pick out 2 points, again, you can pick out any 2 points. I always like to start at an axis if I can. So there's a point, here's another point. So we can create that right triangle, the rise over run. Again, determine your sign first. So the slope's going down from left to right. So we have a negative slope. And our rise there is 3 units, run is 1. So -3 over 1, or just a slope of -3. For our other line there, picking out 2 points again, now we got a positive slope. So rise over run. And we can see that our rise there is 1 unit, run 2. So we got a slope of 1/2. All right, so moving on. Little slope matching activity to get started with. Identifying the graphs whose lines may have the given slope, then describe your strategy for matching the graphs to each one. All right, so if we're looking at, let's say A. A looks like we have a slope that's increasing, so it's going to be a positive slope. And to me, it looks flatter than what the parent function would be, of just y equals x. So we're probably looking for a slope less than 1. So I'm going to say that would probably be A, 1/4 down there, this one right here. B, definitely a negative slope, very steep negative, so we're above 1. So B might be letter D. That might match up to D, it's -3. C, we have a horizontal line. Horizontal line's the easiest one here. We got a slope of 0, so that probably would be B, not probably, would be. Letter D looks a lot like B does. We got a very steep negative slope, so probably letter D. And then E, we got a positive slope, looks slightly steeper to me than what the parent function might be, so a little bigger than 1. So C would match up perfectly of that one, 5/4. And then F is a lot like letter A was. It's 1/4 would be my guess. It is positive, but it looks flatter than the parent function. So I'm going to say A. And how did we use these graphs to estimate slope? So just as I was talking through it, first I said positive or negative slope. So I'm going to say positive versus negative. And then also the steepness to make some estimates off what that slope might be. All right, activity 2.1, analyzing a linear relationship from a table. Ron has a player's card for the arcade at the mall. His player card keeps track of the number of credits he earns as he wins games. Each winning game earns the same number of credits, and those credits can be redeemed for various prizes. Ron has been saving his credits to collect a prize worth 500 credits. The table and graph show the number of credits Ron had on his game card at various times today when he checked his balance. Okay, so it looks like, first of all, when he's starting off, before he's won any games, his card is starting with 120 credits. We have that initial value of 120, which means it's not proportional because it doesn't start at 0, 0. So it doesn't pass through 0, 0. So again, back to the meaning of that ordered pair 0, 20. I mentioned it a minute ago. It's our initial value. It's our y-intercept. Let me redo that. It'd help if your math teacher could spell. There we go, initial value. Okay, so that's our starting point. It's starting with 120 credits when he's won 0 games. And then it says use the graph to determine the slope of that line and then explain the meaning of the slope. So if we're going to go pick out 2 points here in our slope, I'm going to say we have a point here and a point here. We have a positive slope. The line's going up, so our rise from 120 to 200 is up 80. And then our run from 0, don't like that crooked line, from 0 over to, looks like 10. So 80 divided by 10 would give us a slope of 8. So our slope would be 8. So the meaning of the slope in terms of this problem would be he's earning 8 credits for each game he plays, because our input is the number of games won, each game he wins. Because our input is the number of games won, our output is his credits. So it's increasing 8 credits per game he plays, which would be his unit rate. All right, so analyzing Rhonda's reasoning, explain why reasoning is incorrect. She listed that at 440 credits, he had won 40 games, so she just divided and got 11 credits per game. Well, that's not her slope. That is 1 point. We need to use 2 points to determine the slope, to the rate of change. She's just picking that 1 point where at 440, he had won 40 games. So that doesn't take into account that he started with 120. So we need to be able to use 2 points to find the actual slope. Okay, 5 said before Ron started winning games today, how many games had he won for which he had saved the credits on his player's card? Show his work. So in other words, the amount of credits he started with, how many games won worth was that number of credits? So if he had 120 credits, and we know he's earning 8 credits per game win, if we divide that, that means he had 15 games won worth of credits already on the card. All right, next, looking at number 6, after Ron won his 40th game today, how many more credits does he need to win to collect a prize with 500 credits? Well, let's write an equation for this. So we know that he's earning 8 credits per game. So I'm going to say y equals 8 times the number of games he's won. But he's starting out with an initial value of 120. So let's first plug in 40 that he's going to win. This is after he's won his 40th game. So if we do 8 times 40 plus 120, and we can put that into our calculator, 8 times 40 plus 120. That means he has a total currently of 440 credits. Well, if he wants to win 500 worth of credits, 500 minus 440, he's got to earn 60 more credits. So again, we know we're earning 8 credits per win. So if we divide 60 by 8, we're going to get 7.5. Now, he obviously can't win half of a credit, or half of a game, I should say. So he's got to get 8 more wins to actually get to that total. We have to round up to 8. All right, so 7, summarize what we know about this scenario based on our analysis. Be sure to include each item listed. The initial values of the independent and dependent variable in the context of the problem. So independent, dependent variable, I'm going to write this all down here. We got a little more space. Our independent and our dependent variables. Independent variable is the number of games he's won. That's our input value. Our dependent value is the credits earned. A sentence explaining rate of change in terms of the context of the problem. So I'm going to leave this up to you to put this in your own words. We just know that our rate of change is representing his number of credits per game he wins. So a sentence explaining that in your own words. And then the final value is the independent, dependent variables in the context of the problem. So again, those final values, your input is your number of games you've won, your output, your range, your dependent variable is the number of credits we have earned. All right, next we're going to look at calculating rate of change from a table. So far we've determined the rate of change from a graph. Now we're going to look at determining rate of change from a table. So we got the same information we're looking at, and we're going to look at how we can determine slope without having the graph. So like we've talked about before, slope is the change in y, delta y, change in y over change in x. So what is our up-down movement, our change in y, divided by what is our left-right movement, our change in x. So from 120 to 216, we're going up 96, and from 0 to 12, we're going up 12. So our change in y, 96, divided by our change in x, 12, gives us 8. Same thing we got previously, 8 credits per game that he's won. So we get the same slope calculating it from the table, and you don't have to count between each 2 points. Now, we should get the same value no matter which two rows of that table you choose. So choose which rows you want to work with. Usually I pick rows that have the smaller numbers. If I can avoid negatives or decimals, I always try to do that. Try to make it as simple as possible on you, because any two rows there should work. So A, choose any two values. We did that. We calculated independent variable and their difference, and calculate the difference between the corresponding values of the dependent variable. We did that, the change in y and the change in x. And then we got our rate of change. Excuse me, our 8 is our rate of change, 8 credits per game 1. So there's our unit rate. But we get the same thing we got from the graph earlier. Okay, next is examine each example. Follow the arrows to calculate the slope. Was the slope calculated correctly? Now, if we're looking at example 1. Example 1, they do change in y to change in x. Now, it might look a little different than what we did before. Looks like they picked the first row and the last row, and they worked from the bottom up. That's fine as long as we're going in the same direction for both the x and the y. So the one that we have an error here, you'll notice, is on example 2. Their sign is going to be incorrect because they're doing the change in y going down the table, but then the change in x going back up. What that's going to do is we're going to have the same value as far as the difference, but our sign is going to be off when we calculate our slope. Otherwise, that would work. Okay, so the formal mathematical equation process for finding slope is this equation right here. Slope is equal to y2 minus y1 over x2 minus x1. So in other words, we have 2 points. We can name them x1, y1, x2, y2. As long as we have 2 points, we can find the slope of any given line. Okay, and on the next page, that's just showing us how to use that equation in that example. Looks like you notice they used the point 12, 216 as our first point. So our x1, y1 was this point. And then they used the point 25, 320 as our, oops, sorry, I wrote the wrong variable, x2, y2. Okay, and then plugging those in, y2 minus y1 over x2 minus x1. The one time you have to be careful is if you're dealing with negative numbers. If we're subtracting a negative, got to be careful with your signs and realize minus a negative is going to turn into a positive. But you'll see, get the same slope, same unit rate we've been looking at, whether we got it from the table or the graph before. Okay, 3 wants us to repeat that process, calculating the slope, and just use 2 different points. So I'm going to use, I'm going to use the 44 and 40. I'll use that point again. So 40, 440. And I'm going to use, the 25, 320. And we can repeat that process. So we got change in y. So I move over here, we got a little more space. Or actually, I'll do it up here in this space. So change in y. I'm going to call this my x1, y1, x2, y2. Remember, it doesn't matter which point you call first and second as long as your x1 and y1 are together. So 440 minus 320 over x2, 40 minus 25. Okay, and again, just running out of space here. I'm going to work up instead of down. We're going to get 120 over 15, and again, that divides to be 8. And we should expect to get that same answer no matter which 2 points we use there. So 4, how is using slope formula given a table related to using similar triangles? It's the exact same thing. But all of these are talking about the same concept, which is rise over run to find our slope. All right, so now we're going to calculate the slope just as a few examples from these tables and these points. So from table A, change in y, 9 to 12 is up 3. And now might be a good time to pause it. Try these on your own and then unpause it and just check to make sure you get the right answers. Change in x, 4, so slope. Change in y over change in x is 3 over 4. Okay, if we go to B, your change in y there, 13 to negative 2 is down 15. Again, be careful with your negative numbers. Negative 1 to 0 is up 1. So our slope, negative 15 divided by 1, or just negative 15. Okay, for C, change in Y, 25 to 23 is down 2. Change in X, 7 to 8 is up 1. So our slope, change in Y divided by change in X, negative 2 over 1, or just negative 2. And then the last one, a little unique here. We haven't seen this yet. Change in Y, 9 to 9 is 0. Now, it doesn't even matter now what that change in X is, which in this case it's 11, because 0 divided by anything is going to give you a slope of 0. So what we have there is a horizontal line going through 9 on the y-axis. Okay, and then the final two, we want to use our formula again, x1, y1, x2, y2. That formula is always given to you. You don't need to memorize it. It's just your slope formula. So y2 minus y1 over x2 minus, it all erased. Let me rewrite that. If you need that stuff from above, just rewind your video so you can get that back. So again, y2 minus y1 over x2, 55 minus x1. And if we simplify that, we're going to get 15 over 45. And we can reduce that either in the calculator or if we just do it by hand. 5 goes into 15 3 times. 5 goes into 45. 15 goes into itself. Let me rephrase that. I reduced it by 5. 15 goes into 45. So make it a little easier. 15 goes into 15 one time, and 15 goes into 45 3 times. But again, if you need to do that in your calculator, just to remind you how we can do that, we can type in 15 divided by 45. It's going to give you a decimal, and then just hit the math button and enter on fraction, and it will reduce it for you. So 1/3, which is the same thing we got there. Let's go down. And that keeps deleting on us. So again, rewind it. If you get that little glitch there, it deleted on me. But one more problem, same thing. x1, y1, x2, y2. So y2 minus y1, 3 minus 19 over x2 minus x1. And that gives us negative 16 over 20. And again, if we reduce that, 4 goes into 16 4 times. So it becomes negative 4 over 4 going into 20 5 times. So a slope of negative 4 over 5. All right, for 2, which relationships back in that first question are proportional? Okay, again, if you go back through them, I'm not going to go back through it, but if you can go back up and look through each one, you're going to find that none are. And again, it goes back to what we've been talking about. To be proportional, it's got to go through 0, 0. And 0, 0 doesn't fit in any of those tables. So you could say 0, 0 doesn't fit in any table. And just to give you a couple or one example, one at least, like for instance, if we look at B is the most obvious. They have 0, negative 2. That doesn't fit in the table. If we look at D, Y's are all 9. We're going to have 0, 9. It's not going to go through 0, 0. So that doesn't fit in that table either. Okay, so in completing these sentences about slope, if the slope of a line is positive, then as the value of x increases, y will also increase. So that line will go up from left to right. And then the opposite, if it's negative, it will decrease. That line will go down from left to right. So looking at these next few tables, the one on the right, similar to D we saw on the previous page that created that horizontal line, but you notice first one, x equals 1, all the x's are the same. So what that's going to look like, I'm going to draw each one of these, x, y, xy, put this one in blue. X equals 1 is going to be a vertical line going through 1 on the x-axis. That creates a slope that's undefined. We don't have a slope that's defined of a vertical line. And then y equals 2 is going to be a horizontal line going through 2 on the y-axis. And all horizontal lines, like we saw on the last page, create a slope of 0. So horizontal lines, and I kind of just answered B already, that conjecture, horizontal lines create a slope of 0. Vertical lines create a slope that is undefined. All right, so next, determining if a relationship is linear. So it says we previously used similar right triangles to show that a given line on a graph, if the slope is the same between any 2 points in the graph. The converse is also true. If the slope between an ordered pair and a table of values is constant, then the ordered pairs will form a straight line. So in order to determine if a table of values represents a linear relationship, we have to show the slope. Sorry, we have an announcement going on right now. Got to show the slope is the same between every set of points. So what we can do here is what's called the first differences. Okay, or we can just find the difference between each one of these points and assume and assure that it's the same. So 13 to 28 is up 15, 4 to 9 is up 5. So 15 divided by 5 gives us 3. We can do the same for each one of these. 28 to 34 is up 6, 9 to 11 is up 2, 6 divided by 2 is also 3. And then for the last row, 34 to 47 is up 13, 11 to 16 is up 5. And we're going to see that that gives us 13 over 5. That does not equal 3 like the other two. So this is not linear. It has to be the same for any 2 points in that graph. So D, will the ordered pairs listed in the table form a straight line? No, it is not linear, so we're not going to get a straight line out of that. Okay, so checking a couple more examples like those on the next page. You're going to see here on A, our change here, 7 to 13 is up 6, 2 to 6 is up 4, and 6 divided by 4 equals 3 over 2. So then we try the next row. I'll do this one in red. 13 to 16 is up 3, 6 to 8 is up 2. Okay, that works perfect. 3 over 2. That matches as this one. And then if we try the last one, 16 to 34 is, let's see, 34 minus 16, up 18. And 8 to 20 is up 12. And 18 divided by 12, when we reduce that, is going to give us 3 over 2. So this one, I'll write it in yellow, yes, this is a linear relationship. And then you notice on B, I'm going to show you something else we can check. If all the x's are all changing by 1, you notice all the x's go 1, 2, 3, 4, 5. We know those are the same. If that's the same, all we need to check is the differences in those y values. So this is up 7, up 7, up 7, up 7. So we know, again, that works. Yes, that is a linear relationship. Okay, and that leads to what I was just mentioning. If the values in the x column are consecutive, so 1, 2, 3, 4, 5, and so on, we can check just the differences in the y's that we call first differences and determine if they're the same. We know it's a linear relationship. So that example is showing you that they're all changing by going down 13. So we know that is linear simply based on the first differences. So using that concept on the next page, all of these x values in each one of these tables are consecutive, 1, 2, 3, 4, 5, and so on. So we can just check the change values of the y's. So this one goes up 9, this one goes up 11. So already, no, that one is not linear. For B, 12 to 8 is down 4, 8 to 4 is down 4, 4 to 0 is down 4, 0 to negative 4 is down 4. So there we go, that one works. That one is linear. For C, 1 to 4 is up 3, 4 to 9 is up 5. So those are already different. So no, that is not linear. And then for the last one, we're going to find that each one of these y values is all going up by 3. So that one works. And that one will be linear. All right, so that concludes this lesson here, looking at linear relationships and tables. So again, we don't necessarily need the graph to find the slope of the line. We can always just look at the table and calculate that change in y over change in x.